In this video, we're diving into C++ abstraction. Specifically, we'll explore how to create abstract classes and use pure virtual functions. This is a key concept in object-oriented programming that will help you write more flexible and maintainable code. Abstraction is a fundamental concept in object-oriented programming. It involves hiding complex implementation details and showing only the essential features of an object. Consider it a way to simplify things by focusing on what's important and ignoring the unnecessary. Abstraction helps in reducing programming complexity and effort by hiding unnecessary details from the user. Think of it like this: when driving a car, you only need to know how to use the steering wheel, the pedals, and the gears. You don't need to understand how the engine works internally. That's abstraction in action. Let's delve into abstract classes in C++. An abstract class is a class that cannot be instantiated directly. It must contain at least one pure virtual function, and it serves as a base class for derived classes. Here's an example. We have a class called shape. It's an abstract class. Inside, we have a public section where we declare virtual double area equals 0. This is a pure virtual function. We also have virtual double perimeter equals 0 and virtual void draw equals 0, which are also pure virtual functions. Now let's discuss pure virtual functions in more detail. A pure virtual function is declared with the equals 0 syntax in its declaration. It has no implementation in the abstract base class, and it forces derived classes to provide their own implementation. The syntax is virtual return type function name open parenthesis close parenthesis equals 0 semicolon. Key characteristics of pure virtual functions are: it makes a class abstract, meaning it cannot be instantiated. It creates a contract that derived classes must fulfill. It enables polymorphic behavior through interfaces, and it can have a default implementation in C++11 and later. Let's walk through an abstract class example. Here is the code for an abstract base class called shape. It has protected member, which is string color. It has a constructor, shape with string C, initializing color with C. There are two pure virtual functions. Virtual double area equals 0, and virtual void display equals 0. Here are some key points about this code. Shape is an abstract class with pure virtual functions. Therefore, it cannot be instantiated directly. The equals 0 syntax makes functions pure virtual. Abstract classes can still have constructors, data members, and regular methods. All derived classes must implement the pure virtual functions. Now let's implement some derived classes which inherit the abstract class. Here is the code. Class circle, inheriting publicly from shape. It has a private member double radius. It has a constructor circle taking in string C and double R. It then calls shape's constructor with C and then sets radius to R. It overrides the area function, which returns 3.14159 times radius. There is also an override function called display, which outputs circle colon, then the color, then area colon, then the value of the area. Here are some implementation notes. Circle inherits from the abstract shape class. It must implement all pure virtual functions. The override keyword from C++11 onwards ensures that we're overriding a virtual function. Circle can now be instantiated because it provides implementations for all pure virtual functions. And finally, the derived class can access protected members from the base class. Now let's look at how to use abstract classes in our code. Here's the main function. We cannot instantiate the abstract class shape. Attempting to do so will result in a compiler error. Instead, we create derived objects, such as circle with the color blue and a radius of 5.0, and a rectangle with the color green, a width of 4.0, and a height of 6.0. We can use base class pointers to point to these derived objects. We can create an array of shape pointers and assign the addresses of the circle and rectangle objects to it. This enables polymorphic behavior. We can loop through the array of shape pointers and call the display method on each element. This will call the appropriate display method for each object at runtime. Here are the key points. We cannot create instances of abstract classes directly. We can create pointers and references to abstract classes. This enables polymorphism, allowing us to use base class pointers to access derived class implementations. It provides a common interface for different derived classes and allows for runtime binding of method calls. Let's compare abstract classes with interfaces. Abstract classes can have both implemented and pure virtual methods. They can contain data members and have constructors. A class can inherit from only one abstract class. They are used when there is a partial implementation. On the other hand, interfaces, also known as pure abstract classes, contain only pure virtual functions. They have no data members except for static const members and no constructors with parameters. A class can implement multiple interfaces. They are used to define a contract only. Note that C++ doesn't have a formal interface keyword like Java or C#. In C++, an interface is implemented as a class with only pure virtual functions. Abstract classes with only pure virtual functions are often called interfaces. Let's go over the best practices and give a summary of what was covered. Here are some best practices when working with abstract classes. Use virtual destructors in abstract classes. Use the override keyword for clarity. Keep interfaces focused and cohesive. Prefer composition over inheritance when possible, and document the contract that derived classes must fulfill. Here are some common pitfalls to avoid. Forgetting to implement all pure virtual functions, trying to instantiate abstract classes, creating overly complex inheritance hierarchies, not using virtual destructors, and confusing abstract classes with templates. In summary, abstraction in C++ through abstract classes and pure virtual functions provides a powerful way to define interfaces, enforce contracts, and enable polymorphic behavior. It helps create more maintainable, extensible, and robust code by separating interface from implementation. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.